Okay. Last lecture we have seen summation notation and binomial theorem, and then we know how to find out the expansion of binomial using binomial theorem. Okay. Then we start a couple of problems also. Let us do few more problems and then go on to the next. Now here one important, write down binomial theorem again. So क्या होता है a plus b bracket raised to n is equal to sigma r goes from 0 to n a raised to n choose r into a raised to n minus r into b raised to r. Okay, so if this is the standard statement of binomial theorem, then let us check if a plus b bracket raised to say 6, we get 6 choose 0 a raised to 6 बराबर है a raised to 6 minus 0 plus 6 choose 1 a raised to 5 b plus 6 to choose 2 a raised to 4 b square plus 6 choose 3 a raised to 3 b raised to 3 plus 6 choose 4 a raised to 2 b raised to 4 plus 6 choose 5 a raised to 1 b raised to 5 plus 6 choose 6 b raised to 6. Okay, so if we are following this discipline, then this is our first term. This is our second term. This is our third term. Okay, so for our first term, value of r is 0. For second term, value of r is 1. For third term, value of r is 2. And therefore, this is going to be seventh term, where the value of r is 6. So term number tr plus 1 is equal to n choose r a raised to n minus r b raised to r. This is what is important, and that is what we have put there in the binomial theorem. This is what is there here, and start from 0. That is our term number 1. R is equal to n, that is our n plus 1th term. So if the index is 6, we will have 7 terms. If index is 10, we will have 11th term as a last term. One should note this. Hence, question: find 6th term in the expansion of 2x square minus 1 upon 3x square raised to 10. Find 6th term in the expansion of 2x square minus 1 upon 3x square raised to 10. Answer is minus 896 upon 27. You have to add this because these two powers of x are going to be same in the expansion, they will get cancelled out. So basically this is the term which is free from x. Next problem. Question. Find the coefficient of x raised to -7 in the expansion ax minus 1 upon bx square raised to force. The answer is
Sir, isn't it 210?
462 a raised to 5 upon b raised to 6. That is the answer. Okay.
Sir, I think it should be only 462.
Sir, I think so. It should be 210.
All of them are getting 462.
If you could just cross check if it is 210.
Yeah, I will solve. I will solve on the board. Okay. How do you go about getting any general coefficient will be any binomial term TR plus 1 to be 11 choose R into AX raised to 11 minus R into minus 1 upon bx square raised to R. Okay, so we have to first find out R because we want x raised to -7. So here x raised to 11 minus R divided by x raised to 2R, which is equal to x raised to 11 minus R minus 2R, correct? Should be
Yes, sir.
x raised to -7. This implies 11 minus 3R is equal to -7. Minus 3R is equal to -18. This implies R is equal to 6. That is first part of the story. R is equal to 6. Now, if R is 6, then seventh term is going to be the required term. Term number 7 is equal to 11 choose 6, which is 11 choose 5. A raised to 11 minus 6, which is 5. We need not have to worry about x now because x is going to eventually disappear. Minus 1 upon b raised to 6. That is what it is, and therefore it is a positive sign. A raised to 5 upon b raised to 6. What we need to find out is 11 choose 5. 11 into 10 into 9 into 8 into 7 upon 5 into 4 into 3 into 2 into 1. Okay, so 5 into 2 is 10. 4 multiplied by 2 is 8. And 3 into 3 is 9. So 33 into 14. So that is 3 by 4. 4 14 42 आणि 4 46 sorry 46 46. So the final answer is 462 a raised to 5 b raised to minus 6. Next, consider binomial expansion of 2 plus 5 raised to 7. Find the largest term. Want to find out the largest term, if we want to find out the largest term, then we have to compare terms. Now, majority of you guys have done it wrong in the first place because you thought middle term is largest term. That was your observation with respect to binomial coefficients so far. However, these numbers are distinct, different, 2 and 5. So their weightage is different, and therefore not necessary the middle term is going to be the largest. That largest term might shift to the left or right depending upon the weightage of these two terms. Okay, and therefore let us figure out what is our method of finding out the largest term. T, let us consider when will we come to know that we have arrived. Say for example, in this case, in this particular problem, let me write down first few terms. First term is 128. Second term is 2240. Third term is 16800. Fourth term is 70,000. Fifth term is 175,000. Sixth term is 262500. 218750. And last term is 78125. These are the actual numerical values of the terms. When you add all of them, you will get 7 raised to 7. They are the actual values. And then we see that they increase here, increase compared to previous one, increase compared to previous one, increase compared to previous one, and then decrease compared to previous one, decrease. And therefore, this is going to be our largest term. So how do we catch? Every time we cannot find out all and check. The idea is, suppose this is term number r plus 1, then this is term number r, and this is term number r plus 2, okay, for some value of r. So we want to find out that value, because the moment we have r with us, we will be able to evaluate the term. Okay, so what we will do, the idea that we will do here is, we will compare consecutive terms, and if I want to show which is bigger, then maybe I will compare the ratio. If I take tr plus 1 upon tr, and if this ratio is greater than 1, then the next term, tr plus 1th term, is greater than the previous tr term. If tr plus 1 upon tr, this ratio is less than 1, that will happen here. 2187550 upon 2672500 is going to be less than 1. That means the term is smaller than the previous, and hence we will be able to catch hold of R, term number, and hence R. What is our term number R plus 1 in our problem? Let us do it in general. N choose R is a binomial coefficient into a raised to n minus R is the first term into b raised to R is the second term. That is term number R plus 1. And what will be the TR now? N choose R minus 1. A raised to n minus R plus 1. B raised to R minus. This is what is the ratio we would like to find out, how much it is. But I think we can simplify this a bit, which is going to be easy for us to remember. This is 9 factorial upon n factorial n minus R factorial into R factorial into a raised to, let us do what is this factorial, denominator. So n factorial into R minus 1 factorial into n minus R plus 1 factorial. So factorial, one factorial divided by the other we have done. Then power of a raised to n minus R minus n plus R minus 1 and b raised to R minus R plus 1. Therefore, this TR plus 1 upon TR is going to be n factorial cancel. This is R factorial, R minus 1 factorial. Therefore, in the denominator, you end up getting R. This is n minus R plus 1 factorial, denominator n minus R factorial. Therefore, n minus R plus 1 in the numerator. N cancel, R cancel. You have a raised to minus 1, that means a in the denominator, and b is in the numerator. So this is such a nice expression, TR plus 1 upon TR. Okay, we have to cross check whether it is greater than 1 or less than 1. Now let us see if this is useful to find out value of R in our problem. In our problem, n is 7 minus R plus 1 upon R. B is 5. A is 2. Now we want value of R such that this is greater than 1 and the largest value of R we would like to have. So that, because this upon this is also greater than 1, this upon this is also greater than 1. So we are not interested in all ratios. We are interested in largest ratio. Therefore, we will find out what value of R approximately makes it 1. Approximately what is the value of R that makes it 1. So that we will be able to decide if we reduce R or increase R, what will happen. So let us further simplify this. I hope you are with me. 8 minus R into 5 is equal to 2R. That makes it 8 is 40 is equal to 7R. Is that right? That makes it R is equal to 40 by 7. Let us wait. What does this mean? If R is equal to 40 by 7, the ratio is going to be equal. The ratio numerator and denominator is going to be equal. Can we find out approximate value? Sati sati equal satsang 42 sat 35 5 by 7. That is what it is. So if we take R is equal to 5, actually if we take R is equal to 40 by 7, we will get both the terms equal. The ratio will be 1, right? But R has to be an integer. It is a index. It is a counting index that we are using. Starts from 0 and goes to n. Therefore, R value has to be integer. So suppose now I choose the smaller integer than the value that I have got now. Will that do my job? Because if I take the next one, 6, then what will happen? Let us see. If we put, let us, I mean, this is what is the equation that we have. 8 minus r upon r into 5 by 2. This is what we are comparing. If I put 5 here, if r is equal to 5, what ratio do we get? R is equal to 5 is 3 by 5 into 5 by 2 is equal to 3 by 2 greater than 1. If we put r is equal to 6, what do we get? 2 by 6 into 5 by 2, which is 5 by 6 less than 1. Array, do you understand what is happening? The moment you put r is equal to 6, that means 7th term upon 6th term is less than 1. The moment you put r is equal to 5, it is 6 upon 5th term, which is greater than 1. And therefore, we should fix our value of r equal to 5. And hence, if value of r is equal to 5, then our term number tr plus 1 can be found out very quickly. 7 choose 5 into 2 raised to 7 minus 5 to 5 raised to 5. 7 choose 5 can be written as 7 choose 2, and to perform the multiplication, I am sure you will get this value. Majority got this value in the first place is maybe because, but it is still not for middle term, but you must have compared the two middle terms, this and this, and then you got this is bigger, therefore you reported. But actually the next term is, I pause. In the expansion of 1 plus 2x by 3 raised to 15. Now you are supposed to find the largest coefficient in the expansion of this. Okay, I am coming in 4 minutes. So let us solve, no problem, because this is second problem after we develop the formula. And what is the formula that we have? N minus r plus 1 upon r. Let us do it. Pay attention. tr plus 1 upon tr is equal to n is 15 minus r plus 1 upon r into what is our b? Our b is 2 by 3x.
So 2x by 3, yes, sir.
So b is 2 by 3x and a is 1. So we need not have to worry about 1. Even we need not have to worry about this x also. So we need not have to worry about x. 2 by 3, that is b upon 1. Okay. And this ratio should be equal to 1. If we equate it to 1, what happens? 16 minus r into 2. So 32 minus 2r. That is what is in the numerator, is equal to 3r. Is that correct? 3r, correct. So 32 is equal to 5r. And therefore r is equal to 32 5, which is 6 2 by 5. So this fellow is important to us. Is that right?
Yes.
To 6. R should be less than, so R is equal to 6. Therefore, term number 7, we have to find out the coefficient. Term number 7. So R is equal to 6. And hence 15 choose 6 into 1 raised to
Hello.
15 minus 6 into 2 by 3x raised to 6, and hence term number 7 is coefficient is going to be the greatest. The coefficient will be 15 choose 6 into 2 by 3 raised to 6. And if you want to know what is the power of x, it is x raised to 6. This is important and this is the answer, and may not be this. I think 15 choose 6 is 6435. Oh, good. Find the largest term. Find the largest term the expansion of 4 plus 5x raised to 20 when x is equal to 1 upon 3. I am giving you value of x also. So find the largest term in the expansion of 4 plus 5x raised to 20, and maybe show me in factorial or choose notation. That should be fine. For this is tell me 26 4 raised to
14.
14.
14.
4 by नहीं कितनी
5 by 3.
5 by 3.
5 by 3.
5 by 3
Raised to
raised to
6.
6.
Whole raised to 6.
6. This is the answer. Okay, I think we have played good enough with the largest term, and we should do something else now. Question: find R if A and B have same power in the expansion of cube root of A upon root B plus square root of B upon cube root of A raised to 21. Find R if A and B have same powers in the expansion of cube root of A upon root B plus square root of B upon cube root of A raised to 21. Okay, let us write them in index form. A raised to 1/3 B raised to plus B raised to half A raised to 1/6 raised to 20. R plus 1/8 term will be PR plus 1 is equal to 21 choose R 1 up A raised to 1/3. I have written it. Now let us find out the power of A. A is 21 minus R by 3 minus R by 6. This is the power of A. And what is the power of B? B is R by 2 minus 21 minus R upon 6. Okay, so the equation that we get is 21 minus R by 3 minus R by 6 is equal to r by 2 minus 21 minus r upon 6.
Why is there minus sign not plus sign?
Huh?
21 minus r by 3 minus r by 6, so why is it not plus?
This minus because a is in the denominator, na here.
Yes, sir.
So if we make denominator 6, now let me remove the constant terms. Okay, if you solve this, if you put r is equal to 9, I think we will get LHS. Now 12 by 3 is 4 plus 4 minus 9 by 6 is equal to 9 by 2 minus 12 by 6. That is 2. So 4 minus 9 by 6 is equal to 9 by 2 minus 2. Is this question correct? है 24 वजा 9 15 by 6 5 by 2. Right. So for r is equal to 9, this equation is going to be true. Okay. And that is where we break for 10-14 minutes. You understand this, whatever I have done. This is one variable simple equation which we should solve and get r is equal to 9. After doing these small things, now let us do a big thing. A plus B plus C plus D. Bracket raised to 100. Suppose we want to visualize the expansion of this term. A plus B plus C plus D raised to 100. Now the work that we had done yesterday, if there were 3 terms in the first bracket, 2 terms in the second bracket, then we will end up having 3 into 2, 6 terms. Like that, can you tell me how many terms will be there? I'm not asking how many distinct terms will be there. How many terms?
Sir, I think 400.
Sir, 400.
4 raised to the power
4 raised to 100.
4 raised to 100.
4 raised to 100.
4 raised to 100 number of terms will be there in the expansion. Okay. Will they be all distinct? No, they will not be all distinct. So suppose we write any one of the terms, say a raised to 10, b raised to 20, c raised to 30, d raised to 40. Is this term going to be there in this expansion? Yes. Why? Because all the powers add up to 100. What we need to do, if suppose we want to find out, now, if suppose we wish to find out coefficient of this term, find coefficients of this term in the expansion of this. Chal, let us see how many of you can do it. We did this experiment for smaller powers and smaller terms inside the bracket, but the logic is going to remain same. If a raised to 10, b raised to 20, c raised to 30, d raised to 40 is going to be the term in the expansion, then I have to choose 10 a's from 100 brackets. I have to choose 20 B's from remaining 90 brackets. I have to choose 30 C's from remaining 70 brackets, and then remaining brackets I have to choose. That is how you should frame your answer in English, and therefore one way of answering it is out of 100 choose 10 A's. In how many ways you can do it? 100 choose 10 ways. Okay, now you cannot pick up B, C, D from these 10 brackets because only one term from one bracket. So you have already exhausted 10 brackets. Now how many brackets you are left with? 90. So 10 from 10 A's out of 100 brackets and 20 B's out of 90 brackets and 30 C's out of 70 brackets and 40 D's out of 40 brackets. This is one way of looking at the answer, and if you really expand it, 100 factorial upon 90 factorial into 10 factorial into 90 factorial upon 20 factorial into 70 factorial into 70 factorial upon 30 factorial into 40 factorial into 40 factorial upon 40 factorial into 0 factorial. That makes it 100 factorial upon 10 factorial into 20 factorial into 30 factorial into 40 factorial. One way of looking at it. Another way of explaining is, suppose if you choose A from first 10 brackets, B from first 20 brackets, C from first 30 brackets, and D from last 40 brackets. You will get this term, required term. So it is a question of how many permutations of 10 A's, 20 B's, 30 C's and 40 D's permutation with repetition. Total numbers 100. Repetition of A 10 factorial. Repetition of B 20 factorial. Repetition of C 30 factorial. Repetition of D 40 factorial. Therefore, this is going to be the coefficient of a raised. Do you understand? And therefore, let us write down general statement of this result. General A1 plus A2 plus plus AK. There are k terms inside bracket raised to n. In this expansion, coefficient of A1 raised to A1, A2 raised to A2, A3 raised to A3, AK raised to AK is, before I write is, AK raised to AK, such that sigma AI equal to n. What does this mean? Sigma means add, AI means 1, 2, 3, 4. In such case, I am not even writing the index here. In fact, it is I goes from 1 to k. Sigma I goes from 1 to k. All these indices must add up to n. That is the requirement. All the indices must add up to n. The coefficient such that this happens is n factorial divided by a1 factorial into a2 factorial into a k factorial. This is called Newton's multinomial. Here, no matter how many of them are there inside a bracket, doesn't matter. No matter what is the positive integer power that you have in that bracket, you can always find out a coefficient of whatever term you want. Now, next question in this is, have you understood this? All of you?
Yes, sir.
Okay. If you have understood, I have a question. Question in this is, how now a plus b plus c plus d bracket raised to 100 we did, and we said this is one of the terms that will be there in the expansion, and we found out its coefficient also. Okay, so how many distinct terms in the expansion? Do you understand the meaning of that? A raised to 10, b raised to 20, c raised to 30, d raised to 40 is a distinct term which is present several times. Several means how many times? These many times out of 4 raised to 100. Out of 4 raised to 100 total terms, this term is present this many times, and therefore we call this term as distinct. Okay, so how many such distinct terms will be there in the expansion is a question. The general term is going to be a raised to a, b raised to b, c raised to c, d raised to d, and the condition is a plus b plus c plus d must become 100. So the question that we are asking, how many distinct terms in the expansion, is actually the question in how many ways you can get a plus b plus c plus d is equal to 100, and a comma b comma c comma d can be greater than or equal to 0. This is our friend. This question is familiar to us. A plus b plus c plus d is equal to 100, and all ABCDs must be greater than or equal to 0. Therefore, in how many ways we can achieve that is the total number of distinct terms that we are going to have, and hence the answer is 4 elbow 100, which is 103 factorial upon 3 factorial into 100 factorial. These many distinct terms. That is all about multinomial theorem. Let me give you a couple of problems.
Can we say
Sir,
generally
is multinomial theorem derived with is it a mixture of
Okay. Next question is, find the coefficient of a cube before c in the expansion of 1 plus a minus b plus c raised to n. Answer in factorial notation. Yes. Answer for this question is 9 factorial upon 3 factorial into 4 factorial. And into 1 also you can write, but that factorial is 1. Question 2. Find the coefficient of. Same, find the coefficient of a cube, b fourth, a cube, b fourth, c fifth in the expansion of bc plus ca plus ab raised to 6 numerical. Okay, answer for this is 60.
Sir, can you tell how? I didn't understand this question.
Yes. A cube before c fifth, that is what we want. And it is going to be equal to a raised to n1 plus n2. Let us give some powers. AB raised to n1, BC raised to n2, CA raised to n3. Okay. So this is what is going to be the expansion. N1 plus N2 plus N3 is equal to 6. We know this. Now, बराबर ले लेना. Yes. So
Yes.
a raised to 3 you want, and you have a raised to n1 and a raised to n3 with you, into b raised to n1 plus n2 c raised to n2 plus n3, correct? So n1 plus n3 is equal to 3, n1 plus n2 is equal to 4, n2 plus n3 is equal to 5. Using this, I think we will be able to find out n1 comes out to be 1, n2 comes out to be 3, n3 comes out to be 2, correct? They add up to 6, and therefore our coefficient is going to be 6 factorial upon n1, 1 factorial, upon n2, it is 3 factorial, upon n3 factorial, which is equal to 60. That is our question number 2. And question number 3.
Sir,
Yes.
sir, how did that means after AB to the power n1 into BC to the power n2 into CA to the power n3, after that how did it came means A to the power n1 plus n3?
AB raised to n1 is A raised to n1, B raised to n1,
Oh yes sir, yes sir.
BC raised to n2, and CA raised to n3. Question number 3. Find the coefficient of x raised to 7 in the expansion of 1 plus 3x minus 2x cube raised to 10. Answer numerical.